Welcome. If you're preparing for an Android developer interview, you're in the right place. In this video, we'll walk through the top 25 most commonly asked questions in Android interviews. Whether you're a beginner or an experienced developer, understanding these questions and their answers will help you feel more confident and ready for your next opportunity. We'll cover architecture patterns, memory management, Kotlin features, Jetpack Compose, and much more. Let's get started by exploring the foundational concepts that interviewers love to ask about. One of the first things interviewers often ask about is architecture patterns in Android. The three most popular ones are MVVM, MVP, and MVI. MVVM stands for Model View Model, which separates UI, business logic, and data. MVP, or Model View Presenter, is great for simpler UIs and unit testing. MVI, or Model View Intent, is ideal for apps needing unidirectional data flow and complex state management. Each pattern has its strengths, and knowing when to use each is crucial for building maintainable, scalable apps. Let's break down these architecture patterns further. MVVM uses a view model to bridge the UI and data, making it easy to update the UI automatically when data changes. MVP relies on a presenter to handle user interactions and update the UI, which is great for testing. MVI, on the other hand, manages state with a single source of truth and is perfect for apps with complex states. Understanding these patterns helps you choose the right approach for your project and impress interviewers with your architectural knowledge. Memory management is a critical topic in Android development. Android uses garbage collection to reclaim memory from objects no longer in use. It allocates memory based on component lifecycles and can kill background processes if memory is low. To avoid memory leaks, use weak references for large objects, avoid long-lived context references, and clean up resources in lifecycle methods. Tools like Android Profiler and Leak Canary help detect and fix memory leaks, ensuring your app runs smoothly. Keep your app efficient. It's important to avoid memory leaks. Use weak reference for large objects and be careful with static references to activities or contexts. Prefer application context when possible. Lifecycle-aware components like ViewModel and Live Data help manage UI data without leaking memory. Always release resources in on-pause, on-stop, or on-destroy, and regularly use tools like Leak Canary to catch leaks early in development. Dependency injection, or DI, is a design pattern that provides an object's dependencies from an external source rather than creating them internally. This leads to loose coupling, better testability, and easier maintenance. In Android, DI frameworks like Dagger, Hilt, and Coin are popular. They help you manage dependencies efficiently, making your codebase more modular and easier to test. DI is especially useful for large projects where components need to be reused and tested independently. Performance is key to a great user experience. Optimize UI rendering by using Recycler View and the ViewHolder pattern. Manage memory efficiently by avoiding leaks and optimizing bitmap usage. Use Work Manager for background tasks and asynchronous programming for network calls. Reduce app size by removing unused resources and minifying code with ProGuard or R8. Efficient database access and caching strategies also play a big role in keeping your app fast and responsive. Coroutines in Kotlin make asynchronous programming easier and more efficient than traditional threading. Coroutines are lightweight, non-blocking, and support structured concurrency. You can launch thousands of coroutines with minimal overhead, while threads are heavier and harder to manage. Coroutines are easier to cancel and manage, especially with lifecycle-aware scopes. This makes them ideal for handling network calls, database operations, and other long-running tasks in Android apps. Kotlin, understanding the difference between var, val, and const is essential. Use var for mutable variables that can change after initialization. Val is for read-only variables whose value cannot change once set. Const is used for compile-time constants and can only be applied to top-level or object properties. Knowing when to use each helps you write safer and more predictable code, which is a common topic in interviews. Data classes in Kotlin are designed to hold and manage data with minimal boilerplate. They automatically generate useful methods like equals, hashcode to string, and copy. This makes your code more concise and readable. Data classes are especially useful for representing simple data structures, and their immutability helps prevent bugs. The copy method allows you to create modified copies easily, supporting a functional programming style. Field classes restrict class hierarchies to a specific set of types, making them ideal for representing restricted states or outcomes. They can only be subclassed within the same file, which helps manage possible subclasses and ensures exhaustive when statements. Sealed classes are perfect for modeling states like network results or event handling, providing compile-time safety and clear structure in your code. Inline functions in Kotlin optimize higher-order functions by reducing the overhead of function calls. When a function is marked as inline, the compiler replaces the call with the actual code, which is especially useful for small, frequently called functions. Inline functions are great for lambda expressions and allow the use of reified type parameters, enabling type checks at runtime. Use inline for performance optimization and when working with generics. Spend functions are a core concept in Kotlin coroutines, allowing you to write asynchronous code in a sequential style. Marked with the suspend keyword, these functions can pause and resume execution without blocking the main thread. They must be called from another suspend function or within a coroutine. This makes them perfect for long-running operations like network requests, keeping your UI responsive and your code easy to read. Scope functions in Kotlin apply, let, run with, and also help you write concise and readable code by executing a block within the context of an object. Each has its own use case. Apply and also return the object itself, while let run and with return the result of the lambda. Scope functions are great for configuring objects, performing operations on nullable types, and grouping related actions together. Latnet and lazy are two ways to handle property initialization in Kotlin. Use latnet for mutable properties that will be initialized later, often in lifecycle methods or dependency injection. It can only be used with var and non-nullable types. Lazy is for properties that should be initialized only when first accessed, typically with val. It's perfect for expensive computations or resources you might not need immediately. Extension functions let you add new functions to existing classes without modifying their source code. This is especially useful for enhancing third-party libraries or standard classes. Extension functions improve code readability, promote separation of concerns, and make your codebase more modular. You can call them as if they were regular methods of the class, making your code more expressive and easier to maintain. Higher order functions take other functions as parameters or return them, enabling flexible and abstract code structures. Lambda expressions are anonymous functions that can be passed around easily. Together they allow you to write concise, expressive, and functional code. These features are widely used in Kotlin for operations like filtering, mapping, and handling callbacks, making your code more modular and maintainable. Flow and stateflow are tools for managing asynchronous data streams in Kotlin. Flow is a cold stream that emits multiple values over time and only starts when collected. Stateflow is always active hot, holds a single updatable state, and is perfect for managing UI state and view models. Flow is great for sequences of data, while stateflow is ideal for representing state that changes over time and needs to be observed immediately. Kotlin's null safety system helps prevent null pointer exceptions. By default, variables are non-nullable. Used to declare a nullable type, the safeCall operator lets you safely access properties or methods on nullable objects. The not null assertion operator asserts that a value is not null, throwing an exception if it is. The Elvis operator provides a default value if the expression is null. These tools make your code safer and more robust. Inline classes wrap a single value and are optimized to avoid runtime overhead. They improve performance by reducing memory allocation and preventing unnecessary object creation. Inline classes also enhance type safety, allowing you to create specific types for values like IDs. Since the compiler removes the wrapper at runtime, there's no extra cost for method calls or property access, making your code both safe and efficient. Reified keyword is used with inline functions to keep type information at runtime. Normally, generic type information is erased, but with reified you can perform type checks and casts inside inline functions. This is especially useful for functions that need to inspect or operate on generic types at runtime, making your code more flexible and powerful. Sync and await are used in Kotlin coroutines to handle asynchronous operations efficiently. Sync launches a new coroutine and returns a deferred object representing a future result. Await is called on deferred to get the result once it's ready, suspending the coroutine without blocking the thread. This allows you to run tasks concurrently and wait for their results in a non-blocking way, improving app responsiveness. ViewModel and live data are essential for managing UI-related data in Android. ViewModel stores and manages data for UI controllers, persisting it across configuration changes. Live data is a lifecycle-aware observable data holder that notifies observers when data changes. Together, they help separate UI logic from business logic, ensure data persistence, and enable automatic UI updates, making your app more robust and maintainable. is a Jetpack library that provides an abstraction layer over SQLite, making database management easier and safer. Unlike SQLite, which requires manual SQL queries and migration scripts, Room uses annotations and compile time verification. It integrates with live data and Flow for lifecycle-aware data observation and simplifies migrations. The DAO pattern in Room streamlines data access, reducing boilerplate and making your code more maintainable. Dispatchers in Kotlin coroutines determine the thread or thread pool a coroutine runs on. Dispatchers main is for UI updates. Dispatchers IO is for IO-bound tasks like network or file operations, and dispatchers default is for CPU-intensive work. Dispatchers unconfined starts in the caller's context and resumes in the current thread. Choosing the right dispatcher ensures your app remains responsive and efficient. Live data is a lifecycle-aware observable data holder, perfect for updating UI components when data changes. Mutable live data extends live data, allowing you to set or update its value. Live data is read-only, while mutable live data lets you modify the data. Both ensure updates are only sent to active observers, preventing memory leaks and crashes. They are essential for building responsive and safe Android UIs. Launch modes determine how Android handles activity instances. Standard creates a new instance each time. Single top reuses the instance if it's already at the top of the stack. Single task ensures only one instance exists in the task, bringing it to the front if needed. Single instance runs the activity in its own task, separate from others. Understanding launch modes helps you manage navigation and user experience effectively. Jetpack Compose is Android's modern toolkit for building native UIs using a declarative approach. You describe what the UI should look like based on the current state, and Compose updates it automatically. Composables are the building blocks, and state management is straightforward. Compose reduces boilerplate and makes UI development faster and more intuitive compared to traditional XML layouts. Composition is a key feature of Jetpack Compose. When the state changes, Compose automatically reinvokes the affected composable functions to update the UI. This process is efficient, as only the parts of the UI that depend on the changed state are recomposed. Recomposition ensures your UI always reflects the latest data, making it easier to build dynamic and responsive interfaces. Scaffold is a layout component in Jetpack Compose that provides a basic structure for material design layouts. It can hold a top app bar, bottom navigation, floating action button, and more. Scaffold helps you organize your UI and ensures consistency across your app. It's a convenient way to implement common UI patterns with minimal code. Dependency injection frameworks like Dagger, Hilt, and Coin simplify dependency management in Android projects. They automate the process of providing dependencies, reduce boilerplate, and make your code more modular. DI frameworks also improve testability by allowing you to easily swap real dependencies with mocks or stubs during testing, leading to more reliable and maintainable code. Efficient UI rendering is crucial for a smooth user experience. Use Recycler View for lists as it's more efficient than List View. The view holder pattern reduces unnecessary view lookups. Minimize overdraw by reducing the number of overlapping views, and use tools like debug GPU overdraw to identify issues. These optimizations help your app run faster and feel more responsive. Managing background tasks efficiently is essential in Android. Use Work Manager for tasks that need to run even when the app isn't in the foreground. For network calls and heavy computations, use asynchronous programming with coroutines or RxJava. This keeps the UI thread-free and ensures your app remains responsive, even during intensive operations. Optimizing network calls is vital for performance. Reduce the number of requests by using caching and combining calls when possible. Libraries like Retrofit make networking efficient and easy to manage. For large datasets, implement pagination to load data in chunks, improving load times and reducing memory usage. These strategies help deliver a smoother user experience. Smaller app size leads to faster downloads and better performance. Remove unused resources like images and layouts, and use ProGuard or R8 to minify and obfuscate your code. This not only reduces the APK size but also improves security and performance. Keeping your app lean is a best practice that interviewers appreciate. Efficient database access is key to app performance. Use the Room Persistence library for an abstraction over SQLite, enabling compile time checks and easier management. Perform batch operations instead of single inserts or updates to reduce overhead. Integrate Room with live data or Flow for real-time, lifecycle-aware data updates in your UI. Regularly monitor your app's performance using Android Studio's profiler tools. Analyze CPU, memory, and network usage to identify bottlenecks. Use benchmarking libraries to test specific operations and find areas for improvement. Proactive monitoring helps you catch issues early and ensures your app delivers a smooth experience. Optimize your code by avoiding unnecessary object creation and reusing objects in frequently called methods. Analyze and improve algorithms, especially in critical paths. Efficient code not only improves performance but also makes your app easier to maintain and scale. These optimizations are often discussed in interviews to assess your attention to detail. Implement caching strategies to reduce load times and network calls. Use in-memory caching for frequently accessed data and consider disk caching for larger datasets. Proper caching not only improves performance but also enhances the user experience by making your app feel faster and more responsive. Structured concurrency ensures that coroutines are scoped to certain lifecycle contexts, such as activities or view models. This makes it easier to manage their lifecycle and prevents memory leaks. Coroutines launched within a scope are automatically canceled when the scope is destroyed, keeping your app safe and efficient. Kotlin supports functional programming with features like higher-order functions, lambdas, and extension functions. These tools help you write concise, expressive, and modular code. Functional programming encourages immutability and statelessness, leading to safer and more predictable applications. Lifecycle-aware components like ViewModel and LiveData help manage UI data safely. They automatically handle lifecycle changes, ensuring data is only delivered to active observers. This prevents memory leaks and crashes, making your app more robust and easier to maintain. Succeed in Android interviews, focus on understanding core concepts, writing clean and efficient code, and explaining your reasoning clearly. Practice common patterns, stay updated with the latest tools and libraries, and be ready to discuss your design choices. Demonstrating a solid grasp of both fundamentals and advanced topics will set you apart from other candidates. Android developer community is vibrant and supportive. Join groups, follow experts, and participate in forums to stay updated and get help when needed. Resources like Medium articles, official documentation, and open-source projects are invaluable for learning and growth. Networking with other developers can also open doors to new opportunities and collaborations. Congratulations on making it through the top 25 Android interview questions. By mastering these topics, you'll be well prepared for your next interview. Keep practicing, stay curious, and continue building your skills. Remember, the Android ecosystem is always evolving, so keep learning and adapting. Good luck on your journey to becoming a successful Android developer.